you all have the mock exam the same as AB does, and I'm going to ask you guys to make sure that you kind of take it under the exact conditions that you'll take the one on the 12th. It's 2 questions. And what I'm going to do is I'm going to have them both on Google Classroom as individual assignments. And what I want you to do is take the 25 minutes and just work on it. And honestly, I got it done faster than 25 minutes. I think because I was so scared that I wouldn't, that I had time to go back. So don't rush through it, because I actually, on the AB one I took, I screwed it up because I didn't really read the problem. So I was so scared to just have 25 minutes. But for one problem, 25 minutes is a good bit of time. So make sure that you time yourself, and that you do the one for the 25 minutes and then upload it. I would suggest using some kind of PDF uploader, not just taking a picture. Do y'all have
This is on Google.
this? Will
I mean, not Google. It's on AP Classroom.
No, this will be on Google Classroom. They
well,
yeah, physics is going to be on AP Classroom, and
okay.
but this one is going to be over here. But go ahead, make sure you time yourself. And I don't know if I showed you guys. I have an Android, so I don't have that notes app. I don't know if you all do, but if you have a oh, help me, you all. If you have an iPhone, use the notes app. Load them up that way. If you don't, if you have an Android like I do, I downloaded this. It's just a PDF scanner. It just makes it a lot clearer, and it makes it a lot easier to read. So really try to use a PDF scanner. It doesn't have to be this one. This is just the one that I put on my phone. But it made it a whole lot clearer, because I took a picture with just my phone, and then I took a picture with the PDF scanner, and you could actually, it cropped it for you, and it also brightened it up a whole lot. So I would suggest using one of those for your practice on the mock exam. And with the mock exam, what I'm going to have to do is I'm going to have to turn in your work to the people that the Advanced Kentucky people, and then I get to spend a lovely 2 hours with them on a Zoom meeting grading these. And I'm so looking forward to that. And I get to do that 2 more times with physics and with AB calculus. So fun times here. But anyway, so go ahead tomorrow. Make sure you get that done and do it in the time allowed, because you want to see what you can really do on it. Okay. But that being said, if it were me and I were you, over here on BC Calculus, I put up here in the classwork, I put AP test resources. This is the what you need to know stone code. This is the a one-shot piece of paper that has everything on it. And down here's the BC topics. So it's kind of that one spot. And also that one paper that we saw on the AP site, where they're doing the videos, I would have that. Also, I put on here, they're called I think it's kind of blasphemous, but the AB Calculus Bible, the BC Calculus Bible. You want both of them because you're getting tested on both. But this also has a lot of good stuff in it here too. So don't overload yourself with so much papers and so many things, review stuff, that you don't actually take the test. You know what I mean? A lot of times when it's an open note test, or for me, I spent so much time trying to find one like it that I wasted my time. But have stuff out in front of you, like these mock exams, have them out in front of you. So if there's a similar problem, you can approach it a similar way. But anyway, this is on your classroom thing. So any questions so far?
Have you meant to be screen sharing?
Have I what?
Have you meant to be sharing your screen?
Yes, have I not been?
No.
Y'all, come on. I'm over here doing this on my screen and pointing at stuff and talking about stuff. Okay, over here. Do you see it now? Do you?
Yeah. Yes, we can see it.
Okay, thank you. Right here on your AP Classroom is again, it's called the BC Bible, the AB Bible, and it just has all kinds of stuff in it. Here's one thing I really want to stress to you guys. I've been stressing to AB also. Whenever you use the mean value theorem, the intermediate value theorem, the extreme value theorem, make sure, if you know you're going to have to use those, make sure that you talk about being continuous and differentiable. You have to say why you can use it. Betcha L'Hopital's rule is going to be on there. They are freaking losing their mind over L'Hopital's rule right now. But if you're not sure about those, what I'm going to try to find is a one paper that talks about all the existent value theorems. And I'm going to put that on here too. Anything I found that I think is important that could be useful for you guys, I'm going to put right here in
Is
this.
that like EVT, IVT, MVT, all those?
I mean, this is on
Is that
everything.
what you're talking
Yeah,
about?
that's what I was talking about. I was going to just try from one paper about that, but on
Yeah.
here, they're on here. And the first fundamental theorem, second fundamental theorem, everything is on here, and it kind of breaks it down.
Yeah.
It's pretty cool. It talks about different ways you can do problems, different examples. So it wouldn't be a bad thing to have at your fingertips, and it's going to be right here, so you can have it up, while you're taking a test. But let me also caution you guys. They are also, I cannot tell you the number of times they said, do not cheat, do not cheat, do not cheat. Do not. I don't want to know how you're taking this test. It's your test to take. But I'm telling you guys, if you all have the exact same work, they will find it. They will find you, just like that movie. And you do not want to get sent to every college in the country that you're a cheater on the AP test. I would rather you get a 1 or a 0 than turn in the exact same work and get it wrong. And that's kind of, I'm really worried about that with everybody, just because it's so, I don't know, it's so nice to think about doing, working on it together, but really, please don't. But anyway, so that's just something else to think about. Okay, so again, tomorrow, since you can see it now, mock exam. And I'm going to keep giving you mock exams, because the more mock exams you have in front of you, the more problems you have worked out that you can refer back to if you need to. Okay, so that being said, I was going to jump over here, and this was the mock exam from Wednesday. Okay, please have yours in front of you. And I don't know how you want to do it, if you just want me to just do it, or is everybody okay with A and I just go on to B? Do y'all want me to go ahead and just do A also? What's y'all's thoughts?
Can you go ahead and do A? Because I want to make sure I took the second derivative right.
Okay, let me give you the answers, and then we'll know. The first derivative at 65 is 8/5. The second derivative is -8/375. Now, I'll go ahead and do it also for you. But those were the two answers. So, let me get my board turned on here. And I'll also do the scoring breakdown for you, too. Wow, this is acting funky. Okay. So, we have some tabular data here, and we want to find... we have office workers. Let the twice differentiable function, so that means it's continuous, y equal w sub t, be the amount of workers at the building. Okay, so we have this logistic differential equation. As soon as I saw this logistic differential equation, that made me cringe. And that made me, you know what I did? I Googled logistic differential equation, because part B blew my mind. And I had to Google it for part B. And we have an initial condition. Okay, so if we want to find W prime of 65, let me think how I went about doing this. So they told us right here, this basically, isn't that? Oh, it's that, isn't it?
Yeah.
Yeah. Okay. So what you have to recognize that. So you're going to come in here, and basically all you're going to do for this first one is you're just going to come in here and you're going to say 1/15, and you're going to put in a 65, and then you're going to say 1 minus 65 over 100. Y'all with me there? That sound good so far?
Yeah.
Okay, and then, wait a minute, what am I doing wrong? Oh, I'm stupid. Let me back up for a minute. I'm getting ahead of myself. We want to find it at 65, right? Oh, crap. We want to find it at 65.
Yeah.
So if we want to find it at 65, we're looking at this stuff, right? So if I'm going to sub it in, my y is w sub 65. 1 minus w of 65 over 100. And that's going to equal 1/15. W sub 65, that's 60. And honestly, people, that's how I would leave that answer. I would not take the time to work that out. Now, take the time to work that out, you get 8/5. But I would not take the time to work that out. So what messed me up right here? This guy and this guy should be W sub t. And that's how I got the 8/5. But if they were me, I would put a box around that guy right there, the way it looks, horrible, ugly as it is, and I'd leave it and I'd go on to the second part.
So they'll take that?
Heck yeah. They don't want it. Here's the thing. You do that line right, and over here, you put like 9/5, you don't get the credit.
Yeah.
So you want to, for me, I'm leaving all that alone because I know me, I suck at math. Easy math. I'm not very good at it. So let's take a look at the second one. We have the second derivative. I'm just going to use a t in there right now, and that's just that. So I'm going to have 1 over 15. Take the derivative. And let's go ahead and put the 1 over 15 up front. And I'm just going to do that with it. Okay, I'm just leaving it out there. So I'm taking the derivative of the y. I'm leaving this alone. And then I'm going to say plus. I'm leaving the y alone, the dy right here that was right here. And I'm taking the derivative of the inside. If I take the derivative of the inside, I get a negative 1 over 100. But you have to be careful. It's dy dt. So you have to put the dy dt in there. And that's the derivative. Second derivative. So now we're going to have to come in here and we're going to have to substitute some more stuff back in. But we already know the first derivative is 8/5. So don't reinvent that wheel. Okay. So honestly, once I found out I had this, I would probably throw this in my calculator and get me to 3 decimals because it didn't say you couldn't use your calculator. It's 1.6. So I would just use that. So I'm going to come over here and I'm going to have 1 over 15. And I'm going to replace the dy dt with the 8/5. And I'm going to say 1 minus my y value, we know is 60, plus 60 times negative 1 over 100 times dy dt, again, we said was 8/5. I'd close that bracket up, and I'd leave that as my answer. Now, you know me, that makes me want to cringe. But you do not have to simplify it down. Now, if you want to simplify it down, 8 over 375. Now, it says on here, you have to find the first derivative, we did. You had to find the second derivative, we did. Now, using correct units, interpret the meaning of the second derivative. So, the second derivative at 65 means the rate of the amount of workers in the building is changing, or you can say decreasing, at a rate of 8 over 375 workers per minute, or workers per minute squared, at t equals 65. So you want to go ahead when you're doing this, when you're talking about in the context of the problem, you want to talk about the second derivative at 65. So if I'm coming in here, I'm going to write about it. I'm going to say w, the second derivative at 65 means the rate of the amount of workers. And you can say is changing at a rate of and leave it negative if you want to. Or you can say is decreasing at a rate of. Now, if you say decreasing, you want to take the negative off. So you can say just changing at the rate of, you just leave the sign there. At a rate of workers per minute square, because it's second derivative, it's kind of like an acceleration type thing, at t equals 65. And are they in minutes? I I'll just say t equals 65 because that's what it says. That's what it has right here. Didn't want to talk about a unit. And that's basically nutting it because you have your number or your noun, the rate of the amount of workers. You have your units, workers per minute squared for your answer, and you have your time. So talk to me about that one. Or questions?
My derivative was like completely wrong. My second derivative.
Was your first derivative right?
Yeah, I got 1.6.
Okay.
But,
So,
yeah. I
um,
didn't know how to take that derivative.
so here's the point breakdown. You got 1 point for the first derivative. You got 2 points for the second derivative. But if you did not use the chain rule, you didn't get either one of those points or the product rule. You had it, and I think maybe the second derivative, if you used the product rule but you got it wrong, I think you would get one of the points. But if you didn't use the chain rule, you wouldn't get both points. You also get a point for the correct answer. So I think you could get, like if you did, Nick, if you did the product rule, but you didn't do the chain rule, or if you did the chain rule, if you did one or the other, you would get 1 point there. You get a point for your answer, and you get a point for the meaning in the context of the problem. So this was worth 5 points. Okay. So now, anything else about A or comments? What did you do, Nick?
I distributed the 1/15th y into the parentheses and then took that derivative.
I mean, that should be okay too. Why wouldn't that be okay?
I don't know. I ended up getting, okay. Actually, I didn't put dy dt whenever I took the derivative.
That's what got you. That's what got you. Yeah, you may get a point because you could have distributed. That's actually what I did the first time I did it. You could distribute it and then take the derivative. But if you forget the dy dt, that's what's going to get you that chain rule. And guys, I am seeing chain rule everywhere. They're going chain rule crazy. So you've got to make sure. Anytime you're taking that second derivative, somewhere in there, you're going to have that first derivative in there somewhere. Okay. But yeah, you could have done it that way. If you'd remembered your chain rule, you've been good, probably. Okay. So you want to take a look at B?
Yeah.
Okay, let's take a look at B. B, I looked at B, and I thought, and I went on to C. Because B was hard. Now let me put B, let me get another picture of it, and I'm going to go through it with you. But I had to Google again, logistic thing. Let me do it. Okay, so we are going from 0 to infinity. If we're going from 0 to infinity, we can rewrite this. We can change this up, and we can make it the limit as B approaches infinity. And then we are going to say from 0 to basically a value to B Okay, so that was my first step, my first thing I did. Now, if I'm looking at it, I say, okay, if I am going to antiderive this, I've still got this limit sitting out here. And again, chain rule comes in because you have this. If I'm going to antiderive this, I have to have a 1/3 out front because that 1/3 is going to take care of that 3 with the t. And then I'm just going to have w of 3t plus 25. And I'm going to be going from 0 to b. And if you want to check it, if you take the derivative of this, you're just going to have the derivative of that. The derivative of the inside is 3, and the 1/3 will take care of the 3. So that's where that 1/3 comes from. So I end up with 1/3 the limit as b goes to infinity. So like this thing right here is just a total cheat of, I'm going to sub in the b, w of 3b plus 25 minus, I'm going to sub in the 0. Okay, so now we're to here. This is still messing me up, but I can come in right here. I can look at my table, and my table for this value at t equals 25 is 10. So this is easy. This was the part that messed me up. But if we look back at the problem at the top, it says it's a logistic differential equation. So let me find out where I did. I Googled logistic differential equation. And I found this information. So I'm going to write this off to the side. For a logistic differential equation, and this is just another form of it, dp over dt. Ours was dy over dt, but this is just like a generic of it. You have kp to the 1 minus p over m. So this is like the generic formula for it. Okay, now the m down here, that's our limiting factor. So if you look at our problem right here, because it's a logistic differential equation, it's going to have, it has a horizontal asymptote. It flattens out. It flattens out at that number. So what I know, and I didn't know that, you all, I'll be honest with you all, I didn't realize that until I started doing this problem. And I was good doing the cheat until I got to here. And I thought, what the crap do I do with this? Because what I have the 1/3 of the limit of this. But remember, b is going to infinity, and logistics, they flatten out. They do something like that, and they flatten out a number. They flatten out at the number that's right there. So I can come in here, and I'm going to say 1/3. The limit as b goes to infinity, the highest this is ever going to get is 100 minus your 10. Now, it wants us to evaluate this. So I'm going to finish this up. I'm going to get a 30. So what I have a logistic differential equation at 30. It has a horizontal asymptote at y equals 100 because of that limiting factor right there. So the limit as b approaches infinity of w 3b plus 25, that we just found, that's going to equal 100, and that's why that 100 shows up right there. So b, this is b. There's my answer. B was worth 3 points. You had a point for knowing that you could go from here to here. That was a point. You had a point for using the horizontal asymptote. And then you had a point for your value. So talk to me. That's hard, wasn't it?
Yeah, I got to where I had the limit set up, but I didn't know the whole limiting factor thing.
dp over dt equals kp, all that.
Yeah, I didn't either, y'all. I didn't. And what I try to do with these is I go ahead and when I give you a mock exam like this, I take it too. And so like I can kind of see what messes me up. This is what messed me up. And I sat here right here, for a while thinking, what can I do? What can I do? What can I do? And then I just looked up here and I thought, this has to, I needed some more information. And I went straight to Google and I Googled that right there. And that's when I found this stuff. So don't be scared to Google. If you're stuck and you have everything else done you can do, that's how I figured it out. Now, when I figured it out at the time, I don't know. But now you have it in case you see it again. So logistic differential equation, I know what it looks like just because it's on those graphs. Remember you had a bunch of graphs that you had to know? This was just one of them, that it flattens out on top and bottom. So that's what that told me. But if you didn't know that, you're kind of stuck. So that was B. Do I need to do C? The answer for C is 6 and 5/9. I can run through it real quick if you want me to.
Hold on, I just need to see what 5/9 is. No, I'm good.
Me too.
Tucker?
Yeah, I'm good on C.
Okay, because I don't want to waste our time if we don't have to. Okay, D, Euler's method. Do I need to do Euler's method?
Can you just say what the answer was?
Yeah, we want 90.48.
I'm good.
Anybody else? Just so you know, Part C was worth 3 points. Part C was left Freeman sum was a point, approximation was the point, and the meaning in the context. So make sure that when you're talking about the meaning in the context for Part C, that 1/45 integral means the average number of workers in the building from T equals 0 to T equals 45 is about the 6 and 5/9 workers.
Can you run over the Euler's method stuff real quick? Like, you don't have to spend a ton of time on it. Just kind of like.
Well, we're going from 45 to 85, so we know we have to use the 45 and the 85, and then we have to use 65. Why do we have to use 65?
Because you're having 2 equal steps.
What-
About 20.
Yes. So we have to use the 65. So we have 3 candidates, and then we found the for this 45 and the 65, we found the W sub T for those. If I look up there, that's just right off the chart, right?
Mm-hmm.
Is it? 45 is 45 and 30, 65. I get 58 for W sub T. And then I just subbed them. I subbed both those numbers, the 30 and the 58, into the differential, the dy equals the 1/15th y, blah, 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 the thing they gave us, and got those two values. And then I approximated the 85 from that.
Okay.
And again,
I'm sorry.
that was worth 2 points, a point for the Euler's method and a point for the approximation. Okay, for E, lots of steps to these in there. Okay, for E, is there such a time between 25 and 45 when the first derivative equals 1? Justify your answer. Okay, is there such a time? As soon as you see that, are they asking you what the time is? No. Is there such a time? That's one of the existence. As soon as I read that first piece right there, I knew EBT, MBT, IBT. And then when I saw it was the derivative, C equals 1, that's going to be mean value theorem. So the first thing you have to do here is you have to say W sub T is twice differentiable, which means it is continuous. So by the mean value theorem, by MVT, there is a time C between 25 and 45 where W prime sub C equals 1 and the average rate of change is. So when I did this one, the very first thing I did is I said this equals, and I said W sub 45 minus W sub 25 over 45 minus 25. That equals 1. I showed that. And I said since W sub T is differentiable, and I would write this out, but I'm just writing it shorter here. It is also continuous. So by the mean value theorem, there is a time C between 25 and 45 where W prime sub C equals 1. Okay, and that was worth 2 points. You got a point for doing this, and you got a point for coming up with your answer. Just make sure you have to say with the mean value theorem is continuous, is differentiable, so I know I can use it. Okay with that one? Okay, my last one here, we have a secondary polynomial centered at 65. The answer for this one is 87.733. And it was worth 3 points. Do you want me to kind of walk through it, or what's your thoughts there?
Yeah, because I was off by like 2.
Okay, so scooch it down. Let me cover this up because I'm probably going to need more space than what I got here. Okay, so P2 sub T is going to equal W65 plus W prime is 65 T minus 65 plus, this looks familiar like off that chart, doesn't it?
Mm-hmm.
Okay. So then if we go to work this out, we already know W sub 65 is 60. Plus, we already know that's 8/5 from up top.
Oh, I got it wrong because my answer in part A was wrong.
Okay, now here's the thing. Yeah, that kind of makes sense. Here's the thing, though. If you're doing it right with the wrong answers, you should still get points. You would probably, if you're filling it incorrectly, even if your answer is wrong, but you're filling it incorrectly with your wrong stuff, you should still get it. Okay. So then if I want my W sub 85, I'm going to come in here and put an 85, come in here and put an 85, and just work the math out. So that was, you got 2 points for the second degree polynomial and 1 point for the approximation. So I bet if you did that first line correctly with your wrong answers, you would still get those 2 points because you knew to do it. Does that make sense?
Yeah.
Okay. So do we want to keep doing the next one? Y'all feel like it, or y'all want to do it another time? Up to you all.
I don't care.
Okay. I mean, I'm good
Yeah.
with.
We can go ahead and do it.
Okay, I'm good with rolling. Okay. So again, we have this again twice differentiable for x greater than or equal to -6. Here's a picture of it. Just kind of read through real quick what we got. We have a g sub x equals. We have this over here. And the first thing we have to do is find the limit as x approaches -2. So the first thing I always like to do is I like to go ahead and sub it in and see what I get. So if I sub in the -2 on the bottom, I get e to the 0, which is 1, minus 2 plus 1. I get 0 in my denominator, right? Am I right?
Yeah.
I am right, aren't
I think you are.
I? Okay. I wasn't sure. Maybe sometimes I start questioning myself when y'all don't answer me quick. Okay. So now if we're going to take a look at this, we are going to head and take a look at, let's see what the limit as x approaches -2 of g sub 2x minus 4x. And that's just going to be, if I put the -2 in up here, I get g sub -4 plus 8, right? So now g sub -4, what am I going to do with that? G sub -4, if I look up here, if f is the graph given, but telling us right here, I can come over here and I can say, I'm going to sub in the -4 into this integral right here. And I'm going to have from 2 to -4 of f sub t dt plus 8. If I work that out, I get a 0, correct? Are y'all okay with me doing that? Or I can change it. I can keep going. You want me to show you how that gets to be 0?
No, you're right. That's good. Yeah.
Okay. And then the limit, and you need to show these separately as x approaches -2 of e to the x squared minus 4 plus x plus 1. That is going to be 1 minus 2 plus 1. That's going to be 0 also. You need to show these separately of each other. Okay. And then say by L'Hopital's rule. Okay. So you've shown that they're 0 over 0. I am going to come in here and I'm going to say the limit as x approaches -2. Now I'm going to have, now be careful right here. The derivative of this is 2g prime sub 2x, correct? Y'all good with me there? Because of chain rule?
Yeah.
And then underneath here, God, this gets so ugly. I get, what do I get out here? I get a 2x out front e to the x squared minus 4 plus 1. If I take that derivative. Is that right? Y'all agree with me on that one?
Yeah.
Okay. So then if I sub the -2 in up here, then I get g prime sub -4. And if I work this out, I'm running out of space here. Let me take a quick picture of it and move it over. If I could cram it all in. I'm going to lose some of it, but just come back. Oh, no, I'm not. Let me go. But again, L'Hopital's rule, you've got to show these independently of each other, both equal and 0. And then by L'Hopital's rule, then you start filling it out. So here's my by L'Hopital's rule. So I'm going to have 2 g prime to the negative 4 minus 4 over e to the 0 negative 4 plus 1. And we know that this is g prime negative 4 is just f's of negative 4 because the f's a derivative of the g. And from here, it's just working it out. And you can leave it like this. And you get 4/3. So this is worth 3 points. You get a point for the limit as x approaches 2 of actually figuring this out. So that's a point. You get a point for knowing you can use L'Hopital's rule. So if you screw this up, but you still know, you still somehow get a 0 up here, you still know you can apply L'Hopital's rule, you get a point for that, and you get a point for your answer. So to me, the hard part was understanding how I could go from here to here. Okay. So I ask you more questions on that one?
I'm good.
I got that.
Okay. Tucker, you still with us?
Yeah, I struggled on that one a little bit.
Yeah, that's tough. Okay, so let's take a look at B. Goodness sakes, find the absolute. Okay. Again, as soon as you see absolute maximum, you have to check all of your candidates. So let's take a look at that. I'm going to go ahead and pop this over here. Then we're going to go back and look at the graph. So if I'm looking at my graph, I know I have to do my endpoint. So I've got the negative 6. And let's see what we're going to go. Oh, we're going from, be careful. I almost went to 5. We're just going from negative 6 to 2. Okay. Man, I almost screwed up. So I know I'm going to have the negative 6 and the 2. I'm going to have the negative 4. I'm going to have the 0 also. So I end up with 4 points. My endpoints, the negative 6 and the 2, and the negative 4 and the 0, where we're crossing the x-axis. So those, are y'all good with those being your candidates? And let me tell you the answer real quick. If y'all, the absolute maximum value of g is 2 and x equals 0. Do I need to keep going with it, or are you good with that?
I'm good with that.
I can do it if you need me to.
I'm fine.
No, I got that.
Okay, so I'm not gonna. Okay, so I'm gonna jump over that one. That was worth 3 points. You got a point for knowing all your candidates. Oh, and here's one thing they like that I don't really get because they don't tell you to do it, but they want you to know. To me, this is implied. If you come down here and you say you're negative 6, you're negative 4, you're 0, and you're 2, your candidates, you've shown that, but they're giving you a point for writing that down. So whenever you have to find the absolute max or min, go ahead and say it's when the derivative equals 0, because that's all we did. We just looked at our graph right here and right here. So make sure you write that down because that was worth a point. Your candidates are worth a point, and then your answer with your justification. And your justification is just your chart. Your justification is just where you come in here and you find all of your, these are your x values. You find all your g sub x values. Okay, so this is your justification. Okay, so for the next one, for C, just so I can tell you the answer for this one, it's integration by parts. It's negative 33 over 4. Do I need to go over it?
Yes, please.
Yeah.
Okay. Okay. So I'm going to say, I'm just going to let my u, ooh, gosh, it's so fat. My u equal my x. So my du is going to equal dx. That's pretty self-explanatory. I'm going to let my dv equal the f prime of 2x dx. If I antiderive it, v is going to equal, I have to have the 1/2 out front to get rid of that 2, and f of 2x. So again, that chain rule is coming back to bite you in the butt again. So I'm going from negative 3 to 1, and I am going to have x f prime of 2x dx equals, we're going to come in here and we're going to do our integration by parts. So I'm going to have my 1/2 f of 2x times my x. You okay with that? The uv minus the integral of v. Oops, there's a 2 in there. V du. So now, and right here, I'm going from -3 to 1. So I'm doing the same thing right here from the -3 to 1. So let me kind of do that. So this is kind of one piece I'm doing by itself. Here's the other piece I'm doing by itself. So if I have 1/2 f of 2 minus -3/2 f of -6, that's just where I'm subbing in my 1 and subbing in my -3, minus. Now if I come over here, I am going to get, let's see what we have here. Why do I have a minus 1/4? I have a minus, I don't remember what I'm doing. -3 to 1 of f of 2x, 2, oh, I know what I did. I put a 2 in here, so I had to get rid of it out there. 2x. We are having to do it again. We've got my u, right? And I've got my du. So I end up with, I'm going to go ahead and sub in stuff over here. I get a 1/2 f sub 2 is 0, minus, I'm going to make that a plus, 3/2 f sub -6 is a -5. And I'm going to have a -1/4. I'm changing my bounds, so I'm going from -6 to 2 of f sub u du. And if I do that over here, I get what, a -15/2, and that goes to 0, so I have a -15/2 minus 1/4. Now I'm going to sub in, and if I sub in, I'm going to end up getting, what do I get here? A -5 plus 10 plus a -2, and that's going to give me the -33/4. Like, I would just stop it right there. And that is icky. So you got 2 points for your integration by parts, and you got a point for your answer. So what I'm assuming is if you could do, like, if you got this line right, you would get a point for that. This is what's going to get you that second point, and then that's what's going to get you that third point. Anybody want to say anything?
I just like butchered my integration in that part.
The thing is, guys, they are not expecting you to get this all the way done on test day. They told us that. They said that they are going to load you up, and you can still totally pass even if you totally doink parts of it. Okay? So, if you're...
Is it kind of just making sure the parts that we know how to do, we do well?
Yeah, I think so, because there's so many parts. I mean, look at this. We're down here.
Yeah.
And we still have 2 more parts to go, and this is supposed to be the shorter one of the 2. Okay, so what I would suggest you do on something like this is if you see something like that, like how I skipped that first one with the logistic differentiation one, I skipped that one part. I'm going to get everything done right I can first, and then I'll go back. Sometimes they depend on the ones above them. Sometimes they don't. D shouldn't be as bad. D is the base first law whose cross sections are perpendicular are squares, right, but do not evaluate. So we are going to be going from 2 to 5, and it's going to be f of x squared dx, and you're done. And that's worth a point.
Mm-hmm.
But you can totally do that without having to worry about anything else. For part E, you recognize that it's an infinite geometric series, and then you get your sum. And that answer should be -8.
Mm-hmm.
Right? You got okay with that?
Yeah.
Okay. That last one's kind of nice. Those parts up at the top are tough. These last couple of parts on here at the bottom are bad at all. Okay, so you have a mock test now totally worked out for you. Brian Passwater, he's the guy that's been doing your BC, or him and Tony Record have been doing your BC stuff. So you have a totally worked out one here. Brian has made another one I'm going to give you guys. And I'm not trying to give it to you to like discourage you or anything. I just want you to have as much exposure as you can to as many of these different things they think are important. Okay, because
Yes, ma'am.
Passwater and Record are awesome at this, and they've been readers for years, and they know what BC is much better than me. So I'm going to keep giving you these. I just don't want you to think that I'm trying to like be hard on you by giving them to you. I'm not. I just want you to have lots of examples. Okay. Okay. Well, I am done. Again, I'm just going to jump back. I feel like I ran a marathon doing that. I'm going to jump back over here and make sure you watch a video. Make sure you take this test tomorrow to the best of your ability. Take it and then forget about it. We will go over it. And then we'll have another mock exam on Friday that we'll go over Monday or Tuesday. And then at least give you 3 good mock exams to see, to have in front of you for some good examples. Okay.
Yes, ma'am.
Okay. Well, I'm going to jump off. I've got a class in about 10 minutes to teach. I get to teach a unit
Thank you,
circle to
Ms.
pre-cal. You're welcome. I'm really glad to hear from you guys. So I will talk to you all later. Hey,
Yeah.
and anytime you want to talk like this on Discord, holler at me, and we can all get together and do this. Okay. Okay. Bye, guys.
Were you wait?
Yeah. What?
Did you say something? I think I left a little early.
You left me?